Hello my dear students, this is Akash SD. Welcome to the ASD physics classes. Hope you all are doing really great. So students, in this video we are going to learn force between multiple masses with the help of principle of superposition concept. Okay, and in this video we will solve few important questions based upon NEET, JEE and CBSE exam. Okay, so under this topic you can see very well I have taken here the four masses. You can see M1, M2, M3, M4, and I am going to calculate the resultant force on mass M1 placed at point P. Okay, so let's see the basic. The basic is, see, according to principle of superposition, resultant force on a given mass is the vector sum of individual forces acting on that mass due to all other masses. Okay, now let's see, let's talk about the system. Let a system contains n point masses m1, n2, m3 dot mn, but here for the simplicity I have taken only 4 masses. Okay, then by the principle of superposition, resultant force on m1 due to all other masses is given by here. Okay, so here you can see very well on mass m1 we are going to find out the resultant force. Now this mass m1 will experience how many forces? You can see very well this will experience 3 forces. Okay, so let's take here this distance is r1 and here this force I can write here F12, force on 1 due to 2. Here m3 is there, so I have taken here, let's take here r3, and this force is given by, I can write here F13. Okay, and here m4 is there, so let's take, I have written here r4. Okay, and let's take here this force will be how much here? Now just guess, it will be F14. Okay, so 3 forces are there. So according to the system we can write here the net force on mass m1 is given by, what is this, F12 plus we can write here F13 plus F14. If multiple masses are there, even I can write here, if in case so many masses are there, F15 dot even I can write here F1n also. Okay, so this is the basic. But how to calculate the resultant force? For that we should know triangle law of vector addition and a parallelogram law of vector addition to add the forces. Okay, because force is the which quantity? Vector quantity. You have to be very, very careful. So here we are going to learn the basic parallelogram law of vector addition. You have learnt also before, but let's see the recap. If two forces F1, F2 are making angle theta with each other, then magnitude of their resultant force is given by, okay, so let's take here I have taken here 2 forces are there. Let's take, this is the force F1, okay, and this is the force F2. This F1, F2 are the adjacent sides of a parallelogram. Okay, these are the 2 sides, and this I have just make here the dotted line for the parallelogram. The angle between F1 and F2, how much here? Theta. Okay, then the resultant of these forces is given by the one of the diagonal of the parallelogram. Okay, and let's take, I am writing here, this is FR. Okay, so if I talk about here in a vector form, so vector form, what can I write here? This FR means I can write here F1 plus F2. Okay, after that if I talk about here the magnitude, so what is the magnitude here? I can write here, see, mod FR here. Okay, or I can just write FR also. Okay, so what is the formula is there? I think so you know very well. F1 square plus F2 square plus 2F1 F2 into cos theta. Okay, and if in case both these forces are equal in magnitude, F1 equal to F2 equal to F, okay, then in this situation we can write here this mod FR will be equal to 2F cos theta by 2. Okay, 2F cos theta by 2. So this thing you should remember that here. This is the vector form, magnitude when the forces are different, and you can see very well the magnitude when the forces are same. Very, very important here. Is it? Kindly see here very well. Okay, now after that we will see here some cases and all. So let's take here the topic is resultant force between multiple masses. Okay, so under the case 1 we are going to see 3 identical masses at the vertices of an equilateral triangle. So here I have taken here the 3 masses M, 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 and the side of the equilateral triangle, how much here? D. So I have taken here, let's take, this is mass 1, this is mass 2, and this is mass 3. Okay, and I have selected this mass M3. Okay, so in this situation just see and tell me this mass m will experience how many forces? Two forces, is it? Due to this mass m, it will experience one force towards here, is it? This is the towards force is there, okay. This one I can write here, what is this? This will be, I can write here F31, okay. Similarly, due to this 2, again attractive force, gravitational force is always attractive. So here I can write here what? Just guess, F32, force on 3 due to 2, okay. And what are the magnitudes of these forces? If I write here, for example, as it is, F31, what is the formula? From the Newton's law of gravitation, G m into m, that means m square. Distance between them, how much here? D square. So G m square by D square, okay. And if I write here, F32, this one here, this one, F32, you can see very well, m separated by D. So here also I can write here Gm square by D square, and you can see here both these forces are same in magnitude here, okay. After that, next one, if I get here the resultant. So for the resultant, what I have to do here? I have to draw here the one rough parallelogram here, okay. See here, I have drawn here parallelogram. So in this direction, see here, in this direction it will be the resultant towards the centroid here, okay. And let's take, I am writing here F1. And how much this angle? You know very well, in case of equilateral triangle, this angle will be 60 degree, okay. So if I write here the resultant force, what is the formula? We can write here, see, both these forces are equal in magnitude, okay. So directly even I can use the formula here, 2f cos theta by 2, okay. So this will become here 2f into cos 60 degree by 2, that means 60 by 2, how much here? Cos 30. Cos 30 value, what will come here? Root 3 by 2, okay. So if I write here the F1, this F1 will come here, see, 2f into root 3 by 2, okay. This 2 and 2, it will cancel, so it will become here root 3f. And what is the value of the f? F, you know very well, gm square by d square, so it will become here root 3 into gm square by d square, is it? This is the formula, remember that here, very, very important magnitude wise, F1, okay. Even if I see the other situations also, other places also, so see here please, formula we have got it, but sometimes it will be required. Let's take here, this force will be how much? Now we'll see the forces on the individual masses here, see, this will be F12, and after that, let's take, for the example, I'm just writing here, okay, and this will be how much here? This will be F13, okay. Then again we'll make here the one parallelogram, and this will be the resultant force on water 1. So I can write here, what is this here? This is F1. And what is this 3 now? So this will be F3. What is this? F3. Okay, see, this is the F3 here. F3 is there, is it? And this is F1. If I talk about here, let's take this mass, this 2-1. So this will experience force how much here? F21, is it? And due to 3, it will experience force how much here? Kindly see here, F31. Then again, make here some parallelogram. So see here again. Now this force will be how much here? This force will be F2, okay. So all these forces are resultant forces, and all these forces will meet at the centroid here. Now this is the center, towards the centroid is there, okay. So all these forces are equal in magnitude. Maybe directions are different, F1, F2, F3, F1 yellow, F3 red, and F2 is the green. But what will happen that here, their magnitudes are same. So it will be F2 also, and it will be F1 also, okay. Remember that. Can you see here? Is it? Now after that, we'll see for the next one. What is the case 2 here? The case 2, you can see very well, 4 identical masses at the vertices of a square, okay. So here I have taken here the square, and anyhow the sides of the square, how much I have taken here? They are d only, okay. And let's give the name here. I have given here 1, 2, 3, and here 4. Okay, and again let's take, I have selected this mass. So now you tell me this mass m will experience how many forces? 3 forces. Okay, let's take 3 due to 4. This will be the in this direction here. I can write here, what is this? F34. 3 due to the presence of 2. This will be in this direction. What we can write here? F32. Is it? And one more force it will experience. That force will be water. That force will be along the diagonal. For that, see here, I have taken here this line. Okay, because we have to draw the forces along the line, because gravitational force is the centripetal force. Okay, and this force will be how much here? This force I can write here somewhat small arrow. Later you will understand very well what I am drawing here. So it will become here what? It will be here, just think and tell, F31. How much? F31. Okay, so now if I write the forces one by one, you will see that here if I talk about here F34, that means F34 or either F32. Okay, they will have the same magnitude. How much here? Gm square by d square. Why? Because mm separated by d. Here also mm separated by d. So how much? Gm square by d square, and this one I am writing here f. Okay, and after that, if I talk about here the force F31. Now, so this is 3, this is 1. This distance how much from the Pythagoras theorem? D root 2, is it? So I can write here, see, Gm square by d root 2 square. So what this will become here? Kindly see here, Gm square by d square. And what is Gm square by d square? That is f. Okay, so I can write here this one f by 2. Now, so you can see the magnitude of F31 is half of the F34 or F32. That's why this arrow is somewhat small. Okay, now after that, what we are going to do here? Now we are going to find out the resultant of, because we have to add the 3 forces and we know the formula to add only 2 forces only. So what I will do here, first I will get the magnitude of, actually resultant of the magnitude of F32 and F34. That resultant I will add with the F31. Okay, so I am going to write here, see, resultant of, so see, resultant of F32 and F4. Resultant of F32 and F34. So they are making how much angle? Kindly see here. They are making how much angle? See, they are making angle 90 degree here. Is it? So how to get the direction? For that we have to draw here the parallelogram. Is it? So let's draw here the parallelogram here. Now, so see, I am just drawing here the dotted line here. See, this like this here. So the resultant of this will be in this direction, and this I am writing here F3 dash here. Okay, resultant of F32 and F34. So what is the F3 dash? Again, we can use the same formula, 2, and this one you can see very well here, 2f, because magnitude wise both are same. So 2f cos theta by 2. But what is the value of the theta here? You can see with the white color, 90 degrees. So cos 90 by 2. So it will become here the cos 45. So we can write here 2f into 1 by root 2. So this will become here f root 2. Is it? After that, what we are going to do? We are going to add this f3 dash with the f31. Is it now? Because third force is pending f31. So now what we can write here? We are going to write here resultant of f3 dash and f31 is how much? Both are making how much angle? Just see, F3 dash and F31 both in a same direction. That means they are making how much angle? 0 degree. And whenever the vectors are making angle 0 degree, directly we can add them. So I can write here F3 dash plus how much here? F31, because they are making angle 0 degree. Na? Both the vectors in a same direction, either pink color or this blue color. So F3 dash, how much value is there? You can see very well, f root 2 plus what is F31? It is given by f by 2 here. Is it? So I can write here, see, root 2 plus 1 by 2 into f. And what is the value of the f? This one here, Gm square by d square. Okay. So students, this is my formula. Remember that, root 2 plus 1 by 2 Gm square by d square. And you know what will happen that here? If I talk about here the resultant in a which direction? This is along the, this center here. Is it like this here? So if I write here the overall resultant, let me see here. No? I will take here, see. If I write here the overall resultant will be like this. From here also, resultant will be towards the center. Here also, magnitude wise all will be same. Resultant will be towards the center. Okay. So what is this value? This is coming F31. If you will try here, this will come F4. Same basic. When you will try here, this will come F1. And when you will see same basic here, this will come how much here? F2. And all these are lengthwise same. Maybe here in a drawing wise, maybe vectors are not looking equal, but magnitude wise what? They all are same. This length, this length, this length, this length, all should be what? Same. And they should all meet at the center. Okay, is it? So here I have calculated here the F3. This is equal to resultant on mass 2, resultant on mass 1, and resultant on mass 4 also. Okay, remember that here. And remember the value, root 2 plus 1 by 2 Gm square by d square here. Okay, great. Now let's see, the next situation is what here? The case 3, equilibrium. See, equilibrium of a mass at the centroid of symmetric mass distribution. Again I am telling, equilibrium of a mass at the centroid of symmetric mass distribution. So here I have taken here small m, small m. So what will happen that here, let's take here, if I put here one mass, for example m0 at the centroid, at the center. So what is happening that here, let's take this distance is d. How much here this distance here? d, and here how much distance is there? Kindly see here, this will be d by 2, and this will be also how much here? Kindly see, this will be also d by 2 here. Is it up to this only? Up to this, up to this. Now, so in this situation, what will happen there? Kindly see, this m0 will experiences how many forces? 2 forces due to, let's take here, this is 1 and this is due to 2. So, one force in this direction, attractive, I can write here F01, and one force in this direction, attractive. What is there? F02. And what will happen? This will cancel out. This will cancel out. So, resultant force at the centroid will be how much here? 0. Why? Because this vectors, if I write here, this F02 and this one F01, both in which direction? Opposite direction, they will cancel out. Which one? Opposite vectors. Okay. Now students, after that, if we talk about here the second situation, let's take here. Here what will happen that again if I put here one mass m0 at the centroid. So just guess how much force it will experience? Again 0 force, equilibrium. Why? Because if I write here, let's take 1, this is 2, this is 3, basic will be same. So one force in this direction, I can write here F01, and one force in due to 2, F02, and one force due to 3, what is this here? F03. And all these are equal in magnitude, and they all will make how much angle? 120 degree from each other. They all will cancel out here. Okay. So what will happen that here? This resultant force will be how much here? This will be 0. How can I tell that? Because all these vectors will be in a same order and they will make one closed polygon. How can I tell? Let's take here, see, if I'm drawing here, see, this is the F03, na? See here, F03 is upward. After that, F02 in this direction, is it? This is the F02. After that, one more vector will be there, and you can see here, this is F01. So what is happening? They are making one closed polygon, and all are in which order? Same order. You can see tail, head, tail, head, tail, head. Okay, so like that. And they are making how much angle from each other? If I make here the extend the line here, okay, because tail and head is coinciding 120 degree. Similarly, other vectors also 120, 120, 120. Here also it is the equilateral triangle. Maybe it is not looking like that, but this is the equilateral triangle. Okay, great. After that, students, if we talk about here the third one, here also students, if I put here mass m0, this will experience how many forces? How many forces, students, here? 4 forces. So see, this is 1, this is 2, this is 3, and this is 4 here. Is it? Let's draw here the forces. Okay, so see, one force in this direction, see, F01, due to 2, this will become here how much here? F02, due to 3, what is there? F03, and due to this 4, what is happening? F04. Is it? So students, in this situation, again, what is the resultant force? This resultant force will be how much here? 0. Why? Again, all these vectors, they will make one closed polygon in same order here. Okay, so even if you want to see also, see, I'll draw here, see, F03 here. This is F03. After that, let's see, I have drawn here the F04 like this. Then what is there? I have drawn here, see, F01 here. See, F01. And after that, what is pending here? This one here, F02. Is it? See. So what is happening? They all are making closed polygon. Okay, and angle between them how much here? Just draw here the dotted line because tail and head is coinciding. How much angle? 90 degree. And here it is like a square. Okay, see here. So what we understood, if we are keeping any mass at the centroid of symmetric charge distribution, it will experience 0 force. That means in a equilibrium. Okay, great. Now let's see, next one we are going to see what? We are going to see one question here. Okay, so see, important question is there. The question is, see, two stationary particles of masses m1 and m2 are d distance apart. A third particle lying on the line joining the particle experiences no gravitational force. No gravitational force. Now, what is the distance of this particle from m1? Okay, so what we are going to see here in this situation, see, I have taken here m1, m2 separated by how much distance? D distance. And here, what is happening? If I put here one mass, now let's take one mass, I have put here m0 here. m0 mass is there. What is happening? It is not going to experience any force. Okay, so again, let's see here. Due to m1, there will be the one force in this direction. What is this? I can write here F01. And due to 2, one force in this direction. How much here? F02. Okay. And here it is experiencing how much force? 0 force. Okay. So as they are experiencing the 0 force, that means both the forces are balanced force. Okay. So we can tell here as F0 is how much here? 0. F0 is 0. Hence what we can tell? balanced forces are there, magnitude wise opposite, magnitude wise same, and direction wise opposite. Okay, so see what is the F01. See, distance between the masses will be x, so I can write here, see, gm1 into m0 by x square is equal to, what is F02? This is m2, and here this is m0. Okay, so we can write here, see, very very important, gm2 into m0, distance between these masses, how much here? D minus x. This length, how much here? D minus x. Okay, now let's see here, this m0 and m0 cancel, g and g cancel here. Okay, so from here I can write here, see, this will become here d minus x by square is equal to m2 by m1. Okay, next one, let's see here, it will become here d minus x by x is equal to square root of m2 by m1. Now what we can write here, students, this will become here, see, d by x minus x by x means 1 root m2 by m1. Next one we can write here, d by x is equal to 1 plus root m2 by m1, important. And finally I can write here, hence x equal to d by 1 plus root m2 by m1 here. Is it? Very very important formula there, x equal to d by 1 plus root m2 by m1. And here, see here, this distance we are seeing, from which mass? M1 mass. So this will be here m1, m1 will be here m2 by m1 here. Is it? If in case they are asking the distance from m2 mass, so what is the distance from the m2 mass? It will be d minus x. Okay, and then it will be, remember that here, d by, it will become here 1 plus root, it will become m1 by m2. Okay, so what I am going to tell you, I am going to tell you, when you are seeing the distance from the m1, this is 1 plus root m2 by m1, and when you are seeing distance from m2, d minus x, so it will become here 1 plus root m1 by m2. Remember that. Okay, very very important. Okay, next one we are going to see based upon this one question. So you can see very well, 2-point mass small m and 4m are separated by distance d on a line. A third point mass m0 is to be placed at a point on the line such that the net gravitational force on it is 0. The distance of that point from the mass m is how much here? Is it? So story same only, here also you can see it. No? Here I have taken here one mass m and another mass how much here? 4m, and somewhere I kept here one mass m0. Is it? And anyhow the distance between them, what is given here? D. Okay, so what we can tell here, let's take here, they are asking distance from m1 na, distance from m na, see, distance from m. So this m I will take here m1, so m1 is m, so what is m2? M2 will be 4m here. Okay, so after that if I use here the formula, we know the formula, x equal to d by 1 plus, as we are seeing distance from m1, I will write here 1 plus root m2 by m1. Is it? So we can write here what here? This will become here d by 1 plus m2 value how much here? 4m. Is it? And m1 value how much here? M. So this will become here, see, d by 1 plus root 4. Is it? So root 4 means how much? 2, and 2 plus 1 how much here? 3. So we can write here this x value will be how much here? D by 3. Okay, so distance from the mass m will be how much here? Correct answer, d by 3. If in case they ask the distance from 4m, just make d minus d by 3, it will become 2d by 3. Is it? Can you see here? Okay, next one, let's see, we are going to see here. Here we are going to see, very important question is there, see here. 3 particles of equal mass m are located at the vertices of an equilateral triangle of side D. They are moving in a circular path under the action of their mutual gravitational attraction. The speed of each particle is how much here? Okay, in a previous video we have seen when the 2 particle was rotating in a circular path. Now here what is happening? 3 particle is moving in a circular path. Okay, so let's take here, they are moving in this direction clockwise. So this one here is speed how much here? V. Here also is speed how much here? V. And here also we can draw here, this is speed is v. And you know very well, whenever the particles will move in a circular path, they need a what? A centripetal force. So what will happen that here, before also I have talked to you, na? I told you, let's take this is mass 1, this is mass 2, this is mass 3. So this will be F3, and this is the towards center, what is this? F1. And here this is towards center F2. So what will happen that here, this F1, F2, F3 will act as centripetal force. Okay, and then only it will move in a circular path here. So what I'm telling that here, F1, F2, F3, they will act as a centripetal force. Okay, and we'll write here, see, for circular motion. Now, for a circular motion, as I told you very well, this Fc will be equal to F1. Now, Fc equal to F1, Fc equal to F2, Fc equal to F3. I have just taken one particle. Now, so let's take here, what is this Fc? Fc is given here, mv square by r. mv square by r, na? Centripetal force formula, speed is v. And what is F3? F3 we have seen before also in the starting. Case 1 I have told you, resultant force at one of the vertices. So what was there? Root 3 gm square by d. Okay. This formula is there, is it? Now after that what will happen that here, this m and this m will cancel out here. Okay. Then after that we will just simplify this. Kindly see here. Here I can write here, see, this v square b. V square. What is the value of r? Remember that here r means from here to here. R means from here to here r. Remember that here if this is d, then this radius r. No? This radius r, this will be how much here? Remember that here d by root 3. No? This long length is there. This will be d by root 3. Remember that here. Even by basic mathematics also we can get it, not a problem. Okay. So what will be there? This r value will be how much here? D by root 3 is equal to, here we can write here, see, root 3, and here we can write here, see, gm by d. Now, so what we can write here, see, v square into root 3 by d, and here the square is there, is it? And this will be how much here? Root 3 gm by d square. Now, so what this will happen that here, see, from this 1d, this d will cancel out here, okay, and this root 3 will also cancel out. So what is coming? V square equal to gm by d, is it? So what v is coming here? V we can write here is square root of gm by d here. Remember that. What is coming? V is a square root of gm by d. Which option is correct here? The correct option is here option A. Basic is what? This resultant force will act as centripetal force, and this distance how much here? As I have told you, d by root 2. Okay, great. Now let's see, the 4 particle situation is here. The situation is this one, see. 4 particles of equal mass m are located at the vertices of a square of side d. They are moving in a circular path under the action of their gravitational attraction. Again, the speed of each particle how much? Okay, they can move in any direction, no problem. Let's take now in this situation they are moving anti-clockwise. So this is v, here also v, this is v, and this is also how much here? V. Okay, this is the center. So again if I give the name here, 1, this is 2, this is 3, and this is 4. So if I draw here the resultant forces as I have discussed in case 2. So here what will happen that this is the resultant force, we can write here this is the F1. Here also resultant force I can write here F2. Here also resultant force I can write here F3, and here also see here also this resultant force F4. So what will happen that all these forces will act as what? All these forces will act as centripetal force. Okay. So what we can write here again for circular motion, circular motion, for circular path or circular motion. What we can tell here? We can tell here this, anyone you can take. Let's take, I have taken F1. So this Fc centripetal force will be provided by the F1. What is centripetal force formula? mv square by r. F1. Remember in a case 2 what we have done? See, root 2 plus 1 by 2 into gm square by d square here. Okay. Now after that we'll go ahead further. So what this will happen that here, see, this m cancel. Now, and we'll write here, see, v square. What is the value of the small r? Think and tell. In case of a square, so see this length what will be here? You know, this is d, this is d, this all are d only, no? So this is d, this is d. Total how much here? D root 2. So this one how much here? D root 2 by 2. So it will become here the d by root 2. See here, d by root 2 is equal to, anyhow, kindly see, root 2 plus 1 by 2 into what is coming here? Gm by d square. Okay. Now we'll cancel out. What are the things can be cancelled? That will cancel out here. Okay. So here we can write here, this d by root 2 will go this side, and from this d, 1d will cancel out. So I can write here v square equal to, kindly see, root 2 plus 1 by 2 into gm by c. 1 by root 2 will go here, this side, 1 by root 2 will go here. So root 2 will come here, is it? So what we can write here? Root 2 multiply inside, and anyhow d is there. Okay. So root 2 multiply inside. So it will become here 1 plus 1 by 2 root 2 into gm by d, and v means here we have to put here, students, square root. See, this is the formula. This is the formula. This is the formula here. Okay, see, this is the formula. So which option is correct here? Kindly say here. The correct answer is here, option B is the answer. Okay, 1 plus 1 by 2 root 2 gm by d, is it? Now after that here, next question will be based upon the GP. So GP you have learnt in the maths, but see here, I will just tell you infinite geometric progression, GP. Okay, so see here, see. Summation of the infinite GP is given by, see, S equal to A plus AR square plus AR cube dot 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 infinite here. Okay, now what is A? A is the first term and R is called the common ratio of GP. Okay, and remember that here, first point important, if common ratio mod R is greater than 1, then summation of the GP will be infinite. Common ratio how much here? Mod R greater than 1 here. Okay, if I see from the mathematical point of view, this R will be belonging to the minus infinity to minus 1, then union of 1 to infinity. But this is the math part, not that much important. But remember that here, in this situation, what will happen that here? Summation of the GP will be infinite only. Why? Because common ratio is more than 1. Okay, and kindly see here, if I take here, see, some examples I have taken. See, 1 plus 3 plus, now 1, 3, 9, 27, 81, 243, 729, I want to add. This is what? This is the GP, because see, 3 by 1, 3, 9 by 3, 3. R means common ratio, second term by first term here, or we can tell nth term by n minus 1th term. So you can see here, 3 by 1, 3, 9 by 3, 3, 27 by 9, 3, 81 by 27, 3, 243 by 81, 3, 729 by 243, 3. Or we can tell next term we are getting just by multiplying with the 3, 3, 3, 3, 3 again. And this one is moving towards what? This one is moving towards infinite. So its summation will be definitely infinite, because this GP is moving towards infinite. Common ratio is how much here? In this GP. In this GP, common ratio is 3 here. Okay. Now, our point is this one here, important for us. If common ratio mod R is less than 1, that means R value is greater than minus 1 and less than 1, then summation of the GP will be finite, and it is given by, and remember the formula here, this formula is given by A by n minus R, very very important. Okay, and if we talk about here this kind of situation, R should be less than 1. Okay, so see, this GP 1 plus 1 by 3, 1 by 9, 1 by 27, 1 by 81, 1 by 243, 1 by 729. So this GP is moving towards 0. Is it? This was moving towards infinite, so answer infinite only. But this GP is moving towards what? 0. That means here we can apply formula A by 1 minus R. Why? Because in this GP, what is the value of the R? Just think. Second term by first term. So 1 by 3 by 1, what will come here? 1 by 3 only. Even you can check here also. 1 by 9 by 1 by 3, again 1 by 3. Okay. So in this GP, I can use the formula A by 1 minus R. A is first term 1. And here what we can write here? See, 1 minus 1 by 3. So when you will simplify this here, it will come here 1. Here LCM is 3. So 3 minus 1. So what will come here? The GP summation will come here 3 by 2. But remember that here this R value should be less than 1, or this thing should be valid here. See, then only. Otherwise it will not here. Very very important, this GP. Okay, so based upon that, why we have learned that? Because based upon that, question used to come in exam. Okay, here we are seeing from gravitation, but later you will see in electrostatics and all that also. Okay, so see, the question is, a large number of identical point masses M are placed along x-axis at x equal to 0, 1, 2, 4, 8, 16, 32, 64 and all that. Gravitational force on mass M at origin will be how much here? Okay. So see here students, here I have taken the mass at 0, then 1, then 2, then 4, then 8, like this it is going. Okay. So we want to know the gravitational force here on this mass M. So think please, this M and M, what is happening? Distance between them is 1 only. So in this situation, here I should draw all the things, but space is not there, so I am drawing here. Let's take this force, how much here? F01. Okay. After that, principle of superposition we are doing. Now this mass at 0 and this mass at x equal to 2. So distance is increased. Before that it was 1, now it is 2. So when the distance will increase, what will happen that here? The force will decrease here. I am writing here, let's take here F02. Later again force will decrease here for this mass 4, we can write here F04. Again it will become less, I can write here F08. But the thing is what? You can see very well, all these forces, they all are in which direction? They all are in same direction. That means directly we can just add them here. Okay, so resultant force on mass at x equal to 0 will be how much here? F naught 1 plus F naught 2 plus F naught 4 plus F naught 8 dot 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 infinite. Is it? So many masses are there. What is F naught 1? Just think and tell. See, G, Newton's law of gravitation, Gv square by 1 square, because see, 1 distance. Then again, Gm square by this distance here, 2 square. Next one, kindly see, Gm square by how much distance between this masses? 4 square. Like that, we can write here Gm square by 8 square and all. Okay. Now what will happen that here? This Gm square I have taken common. So 1 plus 1 by 4 plus 1 by 16. Here you will get here even 1 by 64 also. Dot dot dot. Is it? And you can see very well this is the Gp and moving towards the 0 because values keep on decreasing. In this Gp, what is happening that here? The first term A is 1. Okay. And common ratio. Just guess and tell common ratio, second term by first term or third term by second term or fourth term by third term. It will come 1 by 4 only. And anyhow, this R is less than 1. We can tell R is less than 1. Is it? So in this situation, what we can use here? We can use the formula A by 1 minus R. A value 1, 1 minus R value 1 by 4. So when you will simplify this, it will come here 4 by 3 Gm square. Which formula used? S equal to A by 1 minus R. Okay, so 4 by 3 Gm square. Correct option is here, option B. Is it? So students, I hope so. This again you can see very well. This is the very important. Okay. So students, I hope so. This video based upon the principle of superposition and questions is very clear to you. Keep studying, keep doing.